The first three terms of an AP are these, respectively. Find the value of x. The first three terms of another sequence are also these three terms, respectively. Verify that when x is 8, the terms form a geometric progression, and find the sum to infinity in this case. Find the other possible value of x that also gives a geometric progression. Okay, then here's the question, so let's have a look at the beginning part then. So here, what have we got? Well, first of all, we've got 2x, and then the next term is going to be 2x plus 4 minus x, isn't it? Because we need, if I wrote that as 2x, I need to take away an x as well, because it's only x plus 4 here. And then the next term will be 2x minus 7. So we're adding on the same amount. So if we think there's nothing here, so that was 0 here, so let's put 0 in. So this is d is equal to 4 minus x, and this will be minus 7 is equal to 2d, so 2d is equal to 2 of these, and that's equal to minus 7. So that tells us then this is 8 minus 2x equals minus 7. So move the 2x over here. I've moved it over there. Move the 7 over here, and it's 8 plus 7 is 15. So we moved that over there, 15, and 2x is 15. Wrote it down from right to left, and x is 15 over 2. So that's the first one then, and we found x. The first three terms of another series are also these. Verify that when x is 8, this is a GP. Okay, part 2 then. X equals 8 gives in these three terms, same three terms again. So we get 2x is 16. The next one will be just x plus 4, isn't it? So 8 plus 4 is 12. And the next term is 2x is 16 minus 7 is 9. Okay, so a will equal 16. R is equal to, well, it would be 12/16, wouldn't it? Which equals 3/4. And if you times that by 3/4 again, you get 9. $16, okay. This is a GP, so we get A plus 16 times R plus 16 times R squared plus 4 3s are 12. 16, when you square it over 16 is 1, and 3 squared is 9. So we verified that for part 2. Part A of part 2. Find the other x value that give rise to a GP. So that was A. Now we need to do B. So we've got 2x, wasn't it? And then we've got x plus 4. And we've got 2x minus 7. So A is equal to 2x if it's a GP. AR is equal to x plus 4. So if we put the 2x in here, okay, we could do AR squared is equal to 2x minus 7. Okay, so what have we got here then? Right, R squared, so we got 1, 2, and 3. Okay, so here, let's have a look what we've got then. 2x R is equal to x plus 4. So that tells us that R is equal to x plus 4. over 2x. So AR squared then is 2x times r squared, which will be x plus 4 squared over this squared. AR squared is equal to 2x minus 7. And then let's see what we get. One of the 2x's will cancel. And we'll get x plus 4 squared is equal to 2x. We're going to move this up to times the 2x minus 7, more than one term, but a bracket. So that tells us then x squared plus 8x, isn't it? Plus the 16. Expand this bracket. X squared, 4 and 4 is 8, and then 4 4 is 16, is equal to 4x squared minus 14x. So let's move everything over onto one side, onto the right hand side. So move this over. 4 minus 1 is 3x squared. Move this over. Minus 14 minus 8 is minus 22x. And then move this over. Minus 16 equals 0. So it has to be 3 and 1 if it factorizes. 3x and x. Now 16 ones wouldn't give 22, would it? 4 fours wouldn't give 22. 8 twos. 8 twos might. 8 twos looks promising. That's a minus. So put a minus there, put a plus here. Equals 0. So 3x squared minus 24 plus 2 is minus 22. Plus and a minus is a minus. 2 8s are 16. So that tells us that x is equal to minus 2/3. Or x is equal to 8. Now let's go back up. Look at part B. Find the other value. This is a GP. Find the other value that gave rise to that, which was... So we had 8. So other value is minus 2/3. So we got the 8 from before. Just looking over the question now, there's one more little thing to mention. I didn't do S infinity on part A, because it asked us to find S infinity here. So A part A here then. Common ratio, so I'll put it here also. S infinity is equal to A, 16, over 1 minus R, which is 3/4. 16 over a quarter is 64.